Hello everyone, welcome to my very first YouTube video. In today's video, we are diving into one of the most awaited new features in the Kubernetes, which is Mutating Admission Policies, was released in version 132 on December the 11th. In my opinion, this is a very powerful addition to the Kubernetes, and I'm here to show you why this feature really matters. I would like to take a moment to give a big shout out to Tech World with Nana. About 4 years ago, when I was just beginning my Kubernetes journey, her videos were my go-to resources. They were incredibly well structured and easy to follow, and they played a huge role helping me build a strong foundation in Kubernetes. Thank you, Nana, for the amazing content and continue to inspire and empower many of us. Before we dive into the details, let's quickly look at what mutation admission policies bring to the table and how they compare to the traditional admission controllers. Enhanced flexibility, declarative management, improved performance, and security and compliance are the key benefits of mutating admission policy. Now let's look this into the details. Enhanced flexibility. Mutating admission policies allows you to modify resource objects such as pods, deployment as they're being created or updated. This means you can enforce rules or add default configuration directly during the admission process without requiring application developers to make these changes manually. For example, imagine you want to ensure that every pod or deployment in your cluster has a specific label for a team ownership, or you want to enforce the environment like such as production, release, development. With mutation admission policies, you can inject these labels dynamically when a pod is created, ensuring consistency across your cluster. Now let's look at the declarative management. Traditional admission controllers often rely on external webhook server to enforce the mutation logic, requiring custom coding and ongoing maintenance. With the mutation admission policies, the mutation logic can be performed declaratively as a Kubernetes resource. This makes the process more Kubernetes native, reduce the need of external dependency and a complex. Next is improved performance. Admission controllers in a previous Kubernetes version, they introduce a network latency because they make HTTPS calls to the external webhook servers, wherein mutating admission policies are processed internally by the Kubernetes API and eliminating those external calls. This reduces the overall time required for resource admission and improves the cluster performance. And finally, security and compliance. Enforcing security and compliance standards is a top priority in the Kubernetes cluster. Mutating admission policies allows you to enforce critical configuration automatically, ensuring that the resource complies with the organization policy without depending on human intervention or external tooling. For example, you can use mutating admission policies to automatically inject security contexts such as running container with non-root user or setting resource limits. This helps and prevents the misconfiguration that could lead to vulnerabilities or instability in your cluster. Now I will walk you through how this feature works in a real world scenario and demo to help you get started. Before we dive into the demo, let's look at the official Kubernetes documents. Here is the Kubernetes 132.0. Let's look at the change log and let's find the mutating. Okay, you can see that v1 alpha 1 was introduced in this version, and in order to use this feature you have to enable the feature gates with mutating admission policies, and also you have to have a runtime config as well. It's a demo time. I don't have any Kubernetes cluster up and running here, so I will be installing Kubernetes with a kubeadm. Just to make sure we are on the right version. Yes, 132.0. That's my pod network cider. There is a typo. Okay, let's copy the config file. Yes, I'm going to install Calico, which is my network plugin with a Tiger operator. And then I have custom resources, which is having my cider. Yeah. Okay, everything is done. Get ports and system. All look good. Let's see all ports. Again typo. Okay, everything is up and running apart from Calico controllers and Calico node. And I know the reason, because we are having only one node cluster, so I have to remove the 10 basically to make sure. Yeah, so now everything is up and running. Now let's see the Kube API resources. So we can see that the mutating admission policies are not enabled. So first thing first, we need to edit the Kube API manifest file to enable this feature. So I'm going to do that now. Let's edit the Kube API manifest file. Not this one. And let's add the feature gets. Equals true. And also we need to add runtime config as well. And we want to enable admission registration .k ats io dot alpha 1 equals true. This is mentioned on the change log of version 132. So save it. This will restart our Kube API. So let's see if Kube API is getting restarted. Still not up. Can we watch it? It should be up in few seconds. So it looks all up and running. Now we will check the API resources again if it is enabled. Yes, I can see that mutating admission policy is enabled and mutating policy binding is also enabled. Okay, let's find out more about mutation admission policies. Let's explain mutation admission policy. Usual fields, API version, which is alpha 1, kind, metadata, and spec. Let's see what specs are. Spec. If you already work on a validation policy, you will be familiarized with all these fields. Failure policy, fail, ignore. I'm not going to go through all the details. You can read later from the explained. Match condition, again similar for validation. Match constraint, similar. Mutation is a specific to the mutation admission policies. So let's go through this. Mutation contains operations to perform on matching objects. Mutation may not be empty. A minimum one mutation is required. Mutations are evaluated in order, means in the sequence, and re-invoke according to the re-invocation policy. The mutation of the policy are invoked for each binding of the policy, and the re-invocation of a mutation occurs on binding basis. Okay, so re-invocation policies are to if needed or never. Okay, I will suggest to go through this when these policies are invoked or re-invoked. Param kind is the same, similar for validations if you are using CRDs to pass on parameters. We will go through the demo of one of the param kind or passing the variables. Now let's look at the mutations in details. Mutations. You can see there are two ways you can apply the mutation. One is apply configuration, which is in YAML format, and then you have a JSON patch as well. I will show you both examples when we apply the mutation. I'm going to show you three mutation policies. One is enforcing image pool policy. By default, we have image pool policy is always. So we will change it to the if not present. The second example will be enforcing a label within the pod, and third is inserting sidecar container within the pod. So let's see the first policy. What we have, as you can see, the mutation kind is mutation admission policy. Then failure policy is fail, either you can have a fail or never. Then you have a re-invocation policy as per the spec. We already gone through this. Match constraint, and then where we want to apply this policy for the pods. And then you have a mutation. Mutation is in this type, you have a patch type is a JSON patch. So we are saying in the JSON patch we will replace at this path, which is the image policy, value if not present. Okay, and then we'll see how it works. So to prove it, first we will run a normal pod before applying the policy. kubectl run x image. This is just quick test. kubectl get pod. Okay, so kubectl pod x. So you can see the default image policy is always. Now what we will do, we will apply this policy. I forgot to show you the image, the policy binding. So kubectl, sorry, cat enforce binding. Binding has nothing, so you can only say here is policy name, what policy it's binding for, and we don't have any exclusion, so we are applying match resources to any actually. So kubectl apply -f and enforce. Okay, we will first, we already seen this, right? So okay, kubectl apply. Now we are applying the policy. Enforce.yaml, and then we will apply the binding as well. Okay, let's see now. So the pod is already running, which will not be applied because the policy itself says when the pod is created or updated. So we'll create another pod. Run nginx new image equals nginx. Okay, kubectl get pods. Edit pod nginx new. This is after we applied an policy. So you can clearly say this pod doesn't have any image policy as always, what we already had. So the mutation has worked here, which is good. We'll look at the next example. Let's look at the new example. So the new example, what we have is to inject environment or label. So I will show you vi policy.yaml. So this is a different patch type. We can see the apply configuration, and what we're doing is we are saying so we creating an object, and then within the object we say metadata, object metadata. Within object metadata, the label we're inserting as an environment, which is coming from the param.spec.environment. So this is what example where I'm passing an parameter. So what kind? So we already mentioned here param kind, and this is API version, which is, and then we have a kind, which is environment env mutation parameters. I will show you how does it come here. So in order to do this, you have to create first CRD. So this is a custom resource definition where you can see the scope is cluster, and then the group is my group k1automate.com, and this is type which is in a v1, and then what we're saying is within the spec environment, and which is in a type string. Okay, and once we create this CRD, so we're going to create a CRD now. Copy. Okay, kubectl apply -f. Okay, and this is just an object holder, so we need to push parameters into this. So cat env parameters. So what we're doing is we are creating an parameter, and we are assigning a value to the environment, which is this environment which we created in CRDs. Okay, which is kubectl apply -f. Okay, so we populated this information now. So this environment is, or environment variable is available, or parameter is available to reference in the mutation policy. Okay, so as you can see, now if I open inject environment policy, So this is how it reference actually. So param kind, so this is my API version, which we already seen, and then it's a kind, basically what kind of this parameter is, and then your reference is params.spec.environment, which is we already defined in that. So we're going to apply this policy. Enforce YAML, and within the binding as well, you need to specify the parameter. So I will show you enforce binding. So we haven't got a parameter. No, not this one, right? So cat. So we have to apply this actually. Inject policy and cat inject. So this is what we're talking about. So as you can see, you need to specify the parameter binding, otherwise it won't work. It has to be defined in the binding as well. And the match resources, as usual, we will not restrict anything here. So we're going to apply binding as well now. Okay, so the binding is applied. So let's see now. So kubectl run env tests. Okay, image nginx. Okay, oops, typo. Okay, kubectl get ports, kubectl edit port env test. So now you can see this environment is released, which was pushed by the mutation. It works very well. Now let's look at our final example, which is inserting in a sidecar container. So let's see the policy. So what do we have as a policy is again in a JSON patch. What we are doing is first we are defining an array, because when we deploy any pod, there is this path is not available, so you have to define it before in advance. Once you define it, then you can define the usual values of that init containers: name, image, and then restrict policies, and then arguments. Okay. Similarly, you will have binding. Usually we don't have any exclusion or any match resources, so it will be applied for everything. So I'm going to apply this. So just to make sure, what we are expecting after this policy is we will be adding an init container with the image busy box, and name will be my init. And then what it's going to do is going to do echo hello from mutation policy and sleep for 200. So let's see. So kubectl apply, you can say run, what should I say, busy, not busy, my init and image equal to nginx. So we should see two containers running within the my init. So my init has the 2 containers, and let's see. Okay, so you can see the container itself is in Nginx, and there will be init container. So you can see the init container and with the arguments, okay, and name is my init containers. So mutation has worked. We can see the logs as well, kubectl logs, and the container name is this. Copy. What was the for name? My init. And how to see this. So it has worked all. And this is the end of demo. If you have any queries or questions, please drop me a comment and I will try to answer these. Have a good time.